Welcome to this AI training video. In this video, you will learn about the processing load data insight in AAI and how you can use it to monitor and balance your job load across schedulers and machines. We will explore the processing load data insight through everyday scenarios faced by automation administrators in managing their jobs efficiently. Before we get to the scenarios, let's first see what you can do with a processing load data insight. You can use the processing load data insight to achieve several load management tasks. Monitor job volume over time to identify intervals of peak processing. Distribute jobs evenly across schedulers and machines. Discover workload patterns and anticipate capacity needs. Examine job execution delays to pinpoint latency issues. And plan for machine maintenance without disrupting operations. Let's also take a look at what you can see in a processing load data insight. Like most data insights in AI, the processing load data insight shows you both the chart and tabular views of your data. You can see a line graph of the processing load plotted on the total number of job executions against an interval of time. The table below shows you the details of your job starts on the schedulers or machines, depending on how you define the data insight. And the legends on the chart represent the relevant schedulers or machines grouped in the data insight. Now let's see how automation administrators use the processing load data insight to monitor and manage their loads. Alex is an automation administrator at Apex 10, a fictitious global financial institution. She uses data insights in AAI to manage her automation workload across different schedulers. In the first scenario, Alex has been alerted about growing job queues related with trading reports. Suspecting latency in job executions, Alex chooses to monitor the AutoSys scheduler, which executes high-volume ETL jobs, and also the Google Cloud Composer responsible for reporting workflows. She starts with creating a new data insight by clicking on the Add Data Insight button on the Data Insights list page. In the new Data Insight page, Alex starts with the basic information by selecting Type, followed by Processing Load. This is where she also sees all the other Data Insight type options. She names this Data Insight AutoSys Composer Load Daily because she needs to monitor the load on these schedulers every day. In the Column tab, she selects the data she wants to see in the data table. She knows that the ones that are grayed out cannot be hidden. For this view, Alex includes finish to start delay since this will help her understand latency issues in job executions. She proceeds to define the primary and secondary sorts in descending order to view the most number of jobs with the highest finish to start delays. In the Filters tab, Alex notices the default date range set to the last 15 days. She selects the 24-hour date range for this data insight. She proceeds to group the insight by scheduler. This will help Alex understand the load on the schedulers. In the filter attributes, Alex picks the Google Cloud Composer and the relevant AutoSys scheduler. She then schedules the data insight to run every day with an email update to her ops team. Alex now has a clear view of the load on AutoSys and Google Cloud Composer schedulers. She first observes an uneven load on Composer while AutoSys seems to have a balanced load. While Alex can see the time interval during which Composer executed the most number of jobs, she observes that the most finish to start delays are during a different time interval. To understand which jobs are running during this interval, Alex clicks on the total number of job starts to view the detailed list. She observes that most of these are related with daily stock reconciliations. To get a granular view of the load during this interval, Alex clicks on the relevant data point on the chart to drill down, and she sees the load by 5-minute intervals. She observes that this is the hour during which both the schedulers experience higher finish to start delays. Alex proceeds to click on the action menu and select Share to share this data insight with her ops team. The team now knows that this is the hour interval for which they need to allocate more processing resources. That concludes the first scenario. Let's do a quick recap of what we learned from this. You can compare the processing load on multiple schedulers in different time intervals. You can drill down to 5-minute intervals of job execution data. In the data table, you can see details such as number of job starts, job start times, and end times in their relevant schedulers. The finish to start data point helps you pinpoint latency issues in job executions. You can explore job details and see their individual start and end times. As with other data insights, you can take actions such as scheduling, emailing, sharing, or printing. Now, let's take a look at another scenario. In this scenario, Alex observes an unusual spike on a processing load data insight. She knows it's a processing load data insight under the type indicator. Alex knows some of these atomic schedulers trigger jobs that generate financial compliance reports. One of these seems to have an increased workload, and she needs to balance the load before the scheduler gets overburdened. Alex observes that the Atomic 100 scheduler is executing a high volume of jobs at specific times. The Atomic Load Data Insight shows the scheduler load over the last 24 hours. She wonders whether this load usage is only specific to a day or if it's a recurring pattern. In the date range filter, Alex can choose date ranges up to 15 days. She switches from the relative to the absolute date range option, where she picks different dates during the past month. She observes the same pattern. The Atomic 100 scheduler is consistently overburdened between 10 a.m. to 11 a.m. and between 3 p.m. to 4 p.m. every day. Alex clicks on the total jobs for this hour to check the job details. She sees several service-level job executions on a Win01 machine. She needs to verify the load on the Win01 machine and the other machines in the Atomic 100 instance. Alex saves a copy of this data insight by clicking on the Actions menu and proceeds to edit the copy from the Data Insights list. She first changes the name of the new data insight to Atomic Load by Machine. In the Filters tab, she selects the Group by Machine option. This gives Alex a view of the load on the Atomic schedulers by their agent machines. In the Filter attributes, she has the option to narrow her analysis by machine, but for this view she doesn't use this feature. The Atomic Load by Machine Data Insight presents the same picture as the one grouped by scheduler. The Win01 machine is overburdened during the same interval. Alex knows that the legends above the chart, which represent their respective machines, are also toggles to hide or show the lines. She turns off the Win01 machine and observes the other machines have a balanced load during this time of the day. Alex now knows she has to redistribute the load to these machines to ease up the overloaded Win01 machine, ensuring a balanced load on her schedulers too. That concludes the second scenario. Let's now review what we learned from this. Using a processing load data insight, you can get a clear picture of the processing demands on your schedulers and machines. You can see up to 15 days of processing load data, whether relative to the current date or any absolute date range in the past. You can quick filter the chart to drill down on data. And with the Group by Machine feature, you can view peak machine performance in their respective schedulers. Now let's take a look at the last scenario. In the third scenario, Alex notices a consistent reduction in processing load on the CA7 scheduler, which handles critical end-of-day processing jobs. She also observes that several jobs are showing unusual execution delays. Suspecting there might be a bottleneck, Alex decides to investigate further using the processing load data insight. Alex first uses the zoom slider to focus on the day with the highest finish-start delay times. She checks the job details for this day and observes most of these jobs are related to payroll processing. Alex wants to check the processing load for that day. She clicks on the data point on the chart for an hourly view and notices an unusual spike at a particular time. She clicks on the data point for that hour to get a granular view of processing load all the way down to 5-minute intervals. She sorts the data table by finish to start delays and observes that this is the interval with high finish to start delays. Alex decides to check the machine on which these jobs are running, but this data insight is grouped by scheduler. Alex goes to the Action menu to save a copy of the data insight. On the Data Insights list page, she selects the copy of the insight to edit it by clicking on the Actions menu from the list view. She first renames the data insight and proceeds to the Filter tab where she can pick the Group by Machine option. In the Filter tab, Alex can also select more CA7 schedulers from the drop-down filter right here, but in this case, there's only one. She then selects the Group by Machine option. In the filter attributes, she views the options but decides not to narrow her search. She saves and runs this data insight to explore all machine load on the CA7 scheduler. Alex observes most of the finish start delays are high on 2-agent machines. Alex concludes that the server hosting the CA7 scheduler may be under-resourced during peak times. She now knows she has to adjust job start times for some high-resource jobs to run during off-peak hours as a solution. She also wants to flag the system for an administrative review. Alex schedules the data insight to run every day with email alerts to the CTO and to her ops team. With that, we conclude the last scenario. Let's look at what we learned from this. From the last scenario, we learned that the slider lets you zoom in or pan out on the timeline. When you do this, the table is quick filtered to show you the related job start statistics. When you filter by scheduler and group by machine, you get to see the load of your busiest machines in the defined scheduler instances. With that, we conclude the last scenario. Let's review what you can do with a processing load data insight again. With a processing load data insight, you can monitor processing load over time to identify potential overloads, redistribute jobs more evenly across schedulers and machines, discover workload patterns and anticipate capacity needs, examine finish to start delays to pinpoint latency issues in job runs, plan for machine maintenance without disrupting operations. That brings us to the end of the overview on the processing load data insight. Thank you.